The wind turbine at the bottom of the hill raises water to a capture barrel. From there, the water is forced to an upper reservoir. The vertical axis Savonius rotor wind turbine drives a horizontal screw rotary pump through a hollow flexible linkage through which the water is raised. The horizontal screw can be seen to the lower right. The horizontal screw forces water through the hollow flexible linkage to an air-water separator which deposits the water into the capture barrel on the tower. In this particular application, the source water level varies significantly. Consequently, the horizontal screw is mounted on a floating deck, tethered so that it can move vertically as the water level changes. The horizontal screw is a 5-gallon pail mounted on an axle supported by bearings at either end. Two independent lengths of flexible half-inch pipe, each about 9½ wraps long, collect water and drive it to the manifold. The greater the number of wraps, the greater the lift, as the water settled in the bottom half of each wrap contributes to the total pressure head. The intakes are positioned at the large end of the pail to compensate for the increased compression of the air between the wraps toward the manifold. The water moves through the flexible linkage, here constructed of sections of braided stainless steel wrapped half-inch rubber hose linked to sections of 3/4-inch galvanized iron pipe with half-inch plastic pipe inserts. The final section of galvanized pipe is mounted to the tower with bearings at each end. This section leads to the air-water separator. Since the inside diameter of the flexible link is small, the water from each wrap is followed by the air from the top of the wrap, thereby almost doubling the total possible lift height. The air-water separator consists of a perforated section of pipe, an inverted spray containment device, and a drip plate which directs the water into the capture barrel. The air-water separator connects through one last section of flexible linkage to the drive mechanism of the turbine. A thermoplastic link is shown, but after numerous failures it was replaced by one more section of braided stainless steel wrapped rubber hose. The modified Savonius rotor turbine has a self-governor to prevent damage from high wind speeds. The turbine is constructed from a plastic drum fastened to an iron pipe frame. The barrel halves are hinged on their outside edges, maintain proper position using a hinged central linkage, and are held in tension at their inner edges by rubber tie-down straps. With low wind speeds, the self-governor's rubber straps pull the two halves of the turbine into the most efficient configuration, as shown on the left. As the rotational speed of the turbine increases, the centripetal force required to hold the halves in place increases, extending the rubber straps as the two halves move out into a less efficient arrangement. The fully extended depiction on the right has been reduced to an efficiency of 0 as the drag in either direction is the same. The actual settled rotational velocity will result in a configuration between these two extremes. The resulting system easily raises water 2½ meters at a rate of approximately 50 liters per hour when driven by a sustained wind speed of over 25 kilometers per hour. The self-priming nature of the horizontal screw ensures that any rotation on a gusty or breezy day will produce water. For more detailed descriptions or reasons for the choices of technologies used, feel free to contact me. My primary interest in this and related designs is in developing appropriate technologies for use in developing countries.